Hello and welcome to the second in Darton College Science Department's Flipped Learning series on forces of motion. This lesson, or this video, is on distance time graphs, how to construct them and how to interpret them. So after watching this video, the aim is that you should be able to use data to construct distance time graphs, interpret the meanings of different sections, and to calculate speed of an object using the gradient of a line in a distance time graph. So the first thing to do when you're constructing a distance time graph is to make sure that you label your axes correctly. Time always goes along the x-axis. Needs a unit, in this case seconds. Distance goes on the y-axis, needs a unit, which in this case is meters. Your scale should always be set out and evenly scaled. So in this case I need to go up to 70. So I'm going to set my axis out like this, with 20 seconds every 4 squares. I need to go up to 40 on my y-axis. I'm going to use the same scale. 20, 40. Next thing to do is to find your plots. So the first thing, meters is 20 and time is 5 seconds. So that's where my first data point is. My second data point is at 50 seconds. And 40 meters. So where the two lines intersect, put my second data point and the third data point, like so. This is one of the strange and rare occasions when drawing a science graph that you can actually join the dots. Normally this would be done with a ruler, and that tells you the story of this distance time graph. You might already be starting to interpret what sections of this line might mean in terms of speed, in terms of horizontal line and things like that. This is about as straightforward as a simple distance time graph gets. An object moving away from its starting point as time progresses. This is a straight line which indicates that this object is travelling at the same speed all the way through its journey. The way you use the graph to calculate the speed is exactly the same way that you would calculate speed from the first video. Speed is equal to the distance travelled divided by the time. Now the distance travelled in this graph is the same as the height of a triangle that you can construct at any point on the line. In this case, the length of the green line. The length of the green line has to take into account the scale of the distance. So in this case it's between 1,000 and 6,000, so it's 5,000 meters. It is not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares, it is 5,000 meters. You must also take into account the distance travelled, which in this case is from about 40 to 250, I'm going to say 210 seconds. Going back to the calculation, you then do your 5,000 for your distance divided by time, which is 210, which gives you 23.8 meters per second. Don't forget your units here. It's always the distance, which is in this case meters, over the time, which is in this case seconds. It doesn't matter where on a straight line graph that you construct your gradient, it's just about picking some useful and appropriate points. This triangle that I've selected here has a height of 15 and a base of 25, giving a speed of 0.6 meters per second, whereas the second triangle for runner P has a height of 40 and a breadth of 50, giving a speed of 0.8 meters per second. We can therefore make our second conclusion about distance time graphs. The steeper the line, the faster the object is travelling. We've now got two new sections of line that we need to consider. The first one is a horizontal section. If you're thinking about this section, you're thinking about the triangle approach again to work out speed. You have to do the height of the triangle divided by its length. This triangle has no height, So whatever you're doing, you're dividing 0 by however long that might be. It could be 10, it could be 100, it could be 1,000. It doesn't matter. The answer to that sum will always be 0 meters per second. That gives us our next conclusion, which is that a horizontal line represents a speed of 0 meters per second, i.e. stationary. Very important distinction on a downward sloping line is that the height of that triangle is not 300 but minus 300. So minus 300 divided by, in this case, 250 gives you a speed of minus 1.2 meters per second. You might think, how can you be travelling with negative speed? Well, the simple answer is that in this case you are going backwards. It's a negative velocity. A downward sloping line means that you're travelling closer to where you started from. So we've now described an upward sloping line, horizontal line, and downward sloping line, including how steep those lines are. The last thing we need to consider is, what about a curving line? What about if a line is flattening off? Or what about if a line is getting steeper? This basically shows us a levelling off line is that speed is getting less. Another word for speed getting less is deceleration. The opposite is true for a line that is steepening. A steepening line shows that speed is increasing, which is acceleration. So in these situations here, in that situation, this line is levelling off, which means deceleration is occurring. And in this situation here, that line is getting steeper, so acceleration is taking place. About as difficult as these questions get is the ability to use a mathematical principle called a tangent. Let's say, for example, that you got asked a question, how fast is this car travelling 700 seconds after it leaves its starting point? Now, unfortunately, at that point, we don't have a straight line, we've got a curve. So what you have to use is a tangent. A tangent is a straight line, or as close as I can get, that touches the line and identifies how steep the line is at that point. From that tangent, you can then construct a triangle as you would normally. The height of this triangle is 250, or minus 250 because it's going down. And the length of this triangle is about 450, 940, is about 490. So by doing minus 250 divided by 490, you can work out the instantaneous speed of this object as it travels 700 seconds after its start point, which is minus 0.5, let's just check your units, meters per second. You can do the same for any tangent. You could be asked to work out the speed 1150 seconds after start point, and there you do a triangle again, calculate the gradient of that line. So that concludes the second video in the Flip Learning series on distance time graphs. In summary, when constructing a graph, time is always on the x-axis and distance on the y-axis, remembering that this is one of the only occasions where you can draw a dot-to-dot line in science that doesn't show a line of best fit or isn't a straight line. Second, the gradient of the line, the steepness, tells you the speed, and you get this by dividing the distance travelled, or the height of the triangle, by the time taken, the breadth of the triangle. Steeper the line, faster the speed. Horizontal lines have a gradient of 0, so they are stationary. If you get a downward sloping line, then you're getting backwards travel, it's going towards the start. And curved lines show acceleration if they are steepening, or deceleration if they are levelling off. Thank you very much for watching. My name is Mr. Clee. Please don't forget to bring your books with your evidence that you've watched this video to your lesson, and bring any questions that you might have along with you as well. Cheers, goodbye.